Hello again from Digicool Things. In my early computing days of the late 1970s, back when we were building our own 8-bit microprocessor systems, it may be hard to imagine now, but we didn't actually have computers back then, of course. So when we wanted to talk to our microprocessor creations, our option was either to get our hands on a serial terminal or to build our own input-output solution. As owning a serial terminal was well beyond the budget of a young hobbyist in the late 1970s, our homebrew solution would generally involve a hex keypad hooked up to an 8-bit I/O port and some form of output, typically via 7-segment LED displays. Later, we would build our own parallel ASCII QWERTY keyboards using surplus keyboards which we wired up in a matrix to connect with a popular ASCII keyboard encoder chip of the day. Like the National Semiconductor MM5740, a 40-pin dual inline keyboard encoder chip. We'd also make some form of homebrew TV typewriter to act as our hobbyist video terminal. Nowadays, for talking to our retro 8-bit microprocessor boards, we can just fire up a free terminal application like VersaTerm on any spare computer with a USB serial interface, and we have ourselves a serial terminal. But sometimes, when we want to feel a bit more nostalgic, it would be nice to be able to fire up a completely standalone, dedicated serial terminal system for talking to our retro 8-bit microprocessor creations. This is where VersaTerm comes in. VersaTerm is a relatively recent creation by David Hansel. You can find VersaTerm at David's GitHub page, which I'll also link in the description. VersaTerm is a versatile, do-it-yourself VT100 compatible serial terminal. You can team up your VersaTerm with either a PS2 or USB keyboard and either a VGA or HDMI monitor, and you then have the modern take a versatile standalone serial terminal, perfect for your standalone early retro computing needs, as well as providing the Gerbers for ordering your own PCBs. David's GitHub repository also provides files for 3D printing your own case to nicely complete the build. On printing the case, I realized that the bolt and nut holes were designed for imperial bolts and nuts. In the metric world, my closest match and my usual case screw of choice is the metric M3 bolt. Unfortunately, these did not fit the imperial bolt holes. In addition, the hexagonal nut recesses were too big to allow locking an M3 nut, so I set about modifying the design to suit M3 bolts and nuts. While doing this, I decided the case would benefit from some text legends to label the ports and also provide a nice VersaTerm label. As I had my Bamboo Lab X1C with AMS multicolour printing, made the legends in a different colour. Here is the result. I've uploaded this modified case design to makerworld.com, and I also shared it with David. David has since added this metric case option to his GitHub repository. So with my case organised and the Gerbers submitted to JLPCB for manufacture, the next was sourcing the parts. The VersaTerm is built around a Raspberry Pi Pico board. I happen to have a spare Pico board lying around unused, so this added to the VersaTerm design being a good fit for me. Of course, I was already sold by the fact that the VersaTerm supports USB keyboards as well as PS2, given that newer keyboards that also provide for PS2 connection mode seem to be getting harder to find. David has also helpfully provided a bill of materials CSV file, as well as a link to add the bill of materials to a DigiKey shopping cart. Although it has been a while since I've ordered from DigiKey, this link made it super easy for me to just open a full shopping cart and simply delete the lines for the parts that I knew I already had, and then complete the order. So here we are a couple of weeks later. I've now received the parts ordered from Digikey, and also have the PCBs that I ordered from JLC PCB. So now I'm all ready to start assembly. So let's start off assembly with the lowest profile components, which would be the 5 1N4148 signal diodes. Okay, now fit the two Schottky diodes, which, just realising, of course, they're surface mount. So being surface mount, I probably should have done them first, but never mind. Right, these are D1 and D2. Right, next up we'll do the resistors. So the first resistors R1 to R8 are 270 ohm. Okay, next we have R9, 10, 11, 12 and R23, which are all 10k resistors. Okay, R22 is a 4K7. Then we have 7 1K resistors. R14 is a 390 ohm. R15 and R18 are 2K2. Then we have 470 ohm. And finally we have two 100 ohm resistors. Right, and that completes all the resistors and all the diodes. Okay, next up we have 7 TO92 packaged MOSFETs to install. Unfortunately, the ones I received are in the pre-lead formed package, which we don't want. The VersaTerm and everything I've designed previously that use MOSFETs, I've used just the straight leaded TO92 package. So I could use some alternatives that I've got in stock, but since I don't have any other use for these, I think I'll just straighten the leads and use these. Okay, I think I'll start by clearing some space. And I'll bring across the connectors so we can see which of the lower profile ones to fit first. So we got connectors, switches, a couple of capacitors we've still got to do, header sockets, and a DC to DC converter. Right, the lowest profile looks like the switch and the mini USB-B connector. So let's do those first. Now the most difficult connector of all is the HDMI connector, as the pins are very small and very close. So let's get that installed and see if we can solder that without too many bridges. Okay, I think the next thing to connect will be the TTL serial connector, and I'll connect the plug to help space it correctly from the circuit board. Otherwise we might solder it too close to the circuit board and the plug won't fit any longer. Right, let's get that soldered. Okay, I think we're now ready for the two remaining capacitors. Right, so let's install the female connectors. We've got two 20-pin connectors for the Pico and a 10-pin connector for the serial driver. Let's get them soldered in. Right, let's do the USB keyboard connector next. And while we're at it, we may as well do the DC connector as well. Okay, let's attach the buzzer. and perhaps also the two buttons. Next we have our DC converter. And finally for this board we have our last three connectors. The 9-pin RS-232, the 15-pin VGA connector, and the PS2 connector. Right, let's get them soldered. Right, our board is nearly fully soldered. Before we do the last solder joints, I've got the Max 232 module, which needs to be connected with a row of 10 pin headers. Now to help line that up for soldering, I've just grabbed a little breadboard. So I'll put the header pins in the breadboard. And I'll grab an IC just to help space it, and then I can drop the module on the pin header and we should be virtually 90 degrees. Right, let's get that soldered. Right, so that's our Max 232 module soldered. We now just need to connect a couple of wires to the Raspberry Pi Pico for the USB data lines. I'm using the Pico H, which is the newer model, which comes with the header pins pre-installed, which just makes things a little quicker. So I've cut off a couple of 8cm lengths of hookup cable, and I'll just strip the ends of the wires. And we'll get them tinned. And let's get them soldered on. Right, then we can attach those two fly leads to the PCB. So TP2, test point 2 was yellow. And test point 3 was orange. Let's get those soldered. Right, and our soldering is all done. So let's turn off the soldering cam and we'll just finish the assembly by plugging in the Pico board. And also the Max 232 RS-232 driver board. And we should be all ready to go. Now I thought I'd be overly optimistic and get it mounted in the case straight away, We'll just assume it's going to work first time. Now it just occurred to me that before I seal this up in the case, we need to upload the firmware to the Raspberry Pi Pico. So although we have access to the USB for the Pico, it is necessary to hold the button on the Pico to put it into programming mode. So let me just take the lid back off. I also have a couple of jack screws for the VGA connector, which I'll attach as well. That was the last component bag from my Digicool order. So let's get those screwed on. Also remove the seal from the buzzer. Now let's hold the button down and plug in our mini USB. Now we can disconnect the USB. And finally finish assembling the case. And there we have it. Finished VersaTerm. Time to give it an initial test. Let's start off by hooking up VGA and our 12 volt power. Unfortunately my lighting isn't very good, but hopefully you can see we have a block cursor in the top of the screen. So the next thing I'm going to need is a keyboard, so I can press F12 to get to the setup menu. Right, I have a new compact USB keyboard, so let's get that plugged in. And let's try F12. Right, we have our settings menu. So if I navigate, I have serial settings, 9600 baud by default, X2 exit, terminal settings, VT102 by default, X2 exit, keyboard settings, layout, US English, screen settings, auto detect, currently VGA, 80 by 30, and color mode. Font settings, okay, looks like we have 4 built-in fonts. Let's leave it at VGA. Exit, bell settings, exit, USB settings, manage configurations, and we've got reset all settings to defaults, and exit. Right, let's hook up our TTL serial interface and see how we go. Right, we have white was receive, grey was transmit, and black was ground. Hopefully I've got those around the right way. Not, I guess we'll soon know. Right, first thing I'm going to need to do is change the serial settings for 38 to 400. Okay, 8 bits, no parity, and 1 stop. CTS ignore. Yeah, we should be right. Let's see what happens. Let's apply power. And we have nothing. Maybe I got the receive and transmit back to front. Let's swap them over. See if that makes any difference. Okay, I think I'll reorganize a bit to make some more room. Put the CPU in the vertical slot so I can move the serial card to the horizontal position. Of course, I'll need to take the lid off the VersaTerm. Shouldn't have been so optimistic. I might also switch back to 9600 board, just so we're at the default of the VersaTerm speeds. Thought I might first try just removing the RS-232 driver board. Right, let's find a ground signal. And perhaps we first have a look at the transmit. So we have a good serial signal coming out of a system. So time to look at the schematic. Now I might move the probe across to R29 and see what we're getting. Alright, let's hit enter again. Now we're getting a much reduced signal, barely fluctuating above about 0.7 of a volt. I think I can see what the problem is. R29 is supposed to be a 1K resistor, But I just noticed that the barcodes on these resistors are brown, black, yellow. And of course yellow indicates we have a 100k resistor there instead of 1k. That'll definitely cause the problem. So there were 7 1k resistors. So the lesson today, I usually always check the value of my components before soldering them in. But I guess since I wasn't using components out of my parts drawers, instead just took the easy route of ordering everything from Digicool, I stupidly took it for granted that all the values were supplied correctly. Even if I'd looked at the resistor, I would have seen the yellow band and it would have warned me straight away. But never mind, time for some rework. So I think now I need to desolder all these 100k resistors and replace them with 1k and see how we go then. Right, we now have all the incorrect 100k resistors replaced with 1k. You can see them because they're metal film, so they're the blue resistors. Let's see how we go now. So I probably shouldn't be as sure of myself, and I'll test it out before putting it fully in the case this time. The TTL RS232. Okay, apologies again about the lighting. Fortunately I have a window next to me, so we're getting reflections on the screen, but hopefully you can make it out. Okay, let's apply power. Oh, and this time, instead of just a block cursor, we actually have an intro screen. VersaTerm 1.0, copyright 2022 by David Hansel. So let's turn our system on. And we have a Sys09. This is at the default 9600 board. Right, I might just unplug it because I forgot to put in the RS232 module, so I might as well complete it. And plug it back in. And I'll hit reset on our system. We have a Sys09. D0000 D02FF. Looking good so far. Let's try setting it back to 38400 board. And I'll change the dip switch. And hit reset. I'll exit out of there. And I'll hit reset. And we're working at 38400. Awesome, success at last. So the only problem was the incorrect value resistors supplied by Digicool. But that was my fault, because as you know, you should always check your component values before putting them in your board. So I'll get the VersaTerm case screwed back together, and the job is finished. I now have a standalone serial terminal without the need for a computer, feeling a bit more like the old days, except I've now got a much better keyboard than I would have had in those days, and a much better display. Superb. I still can't get over not noticing that I'd received 100k resistors instead of the ordered 1k. I've always checked my components before using them. It's why this component tester lives on my workbench. But it has been a long year, and this video has literally taken me weeks to complete, in between constant end-of-year interruptions. Although, I suppose on a positive note, we can call it another great reminder of what you should always do. Check your components and values. Also, I'll note that videoing full product assembly is time-consuming. I know some people find watching electronic assembly incredibly boring, while others find it quite relaxing. Perhaps let me know in the comments whether this is something I should do again, or whether you prefer me skipping detailed assembly. That's it. Thanks for watching.